Hi, my name's Todd Hagerman. I'm in the applications lab at AMADA WELD Tech here in Monrovia, California. Today I'm going to show you how to focus a pulsed ND-YAG laser. Some people ask, what is a laser? A laser is an acronym for light amplification by stimulated emission of radiation. Our laser medium we're using today is a neodymium yttrium aluminum garnet, which the acronym is ND-YAG. We're going to show you a little bit how the process works in focusing, where you go from having nothing, just firing the laser out of focus, where it transfers heat, you melt some material, evaporates it, or you can also eject the material. We're going to show you how to focus the laser properly, set the crosshairs to the spot, and focus the camera so every time you fire the laser, it's in laser focus and optical focus. Welder setup finding focus using your pulse jag laser. Be sure you're wearing approved laser goggles before you start. It's the most important step. We use a 10,000 shim stock, so place a steel coupon under the focusing head. Set your YAG laser to 1 kilowatt, 1 millisecond. At 100%, 3 pulses per second, using 30 cubic feet per hour of argon, and fire the laser. Move the focus head up and down, moving in Z and also moving in X. Go up and down. See, when the plume is on the steel, you'll hear a snapping sound. That's when the laser is in focus. Do it a couple times. Make sure when it has the strongest sound and the highest plume. When the laser is in focus, you'll hear this and you'll see it on the part resembles a feather. Then you turn the laser off, focus the camera to the spot. It does not have to be in the center. You can always move it later. Move the steel over again, fire a single shot with 1 kilowatt, 1 millisecond. Now align the crosshair to the spot. Repeat this step a couple times. I do it 3 to 5 times to ensure the crosshair and spot are aligned. Now wherever you put the crosshair, you are in laser and optical focus. Okay, the importance of being in focus: you have improved quality of welds with a cleaner appearance, more repeatable welds with less variation, increases the power density so less power can be used. You reduce overheating and material distortion, and the laser parameters and material characteristics. Your peak power and pulse width will determine the outcome. Finding focus, you can see we start in the center and we go up and down, moving in Z and also moving in X. Okay? And you can see when the plume is at the highest and the strongest. We do this in 10,000 increments. You can do it from left to right either way. You can also set up a program that can do this. So I'm going to bring the head down in the Z direction, and we're going to go across the part in the X direction and go up and down in Z until you see a plume on the part and you'll hear a snapping sound. That's how you know that we're in focus. So we're going down right now. You can see the part comes into focus. You can see it starting to. You hear the intensity of that plume. That snapping sound lets you know you're in focus, but we can take it in and out to verify where the focus is at and where it goes out of focus. Where the strongest snap or the sound you hear, that's where you're in laser focus. You have the laser in focus. What we're going to do is move the material over. We're going to fire one shot. Okay, we're going to fire one shot and align the crosshair on that part. So you have one shot that's in focus, but your crosshair is off. So we have a crosshair generator here at the station. We're going to move it over. You center this on the part. Looks pretty close, so what we're going to do is move it over and fire it again to verify. Do this 2 or 3 times to make sure that you're in the right location. Before you lock it down. That looks pretty good. We'll do it one more time. Okay, so we're going to lock this down this time. We're going to move this down and we're going to do a seam weld to show you the tracking of it and what it looks like. Now, wherever you put the part, put the crosshair, you're in optical focus and laser focus. You're showing a seam weld, 3 pulses per second, which is 80% overlap, or a hermetic weld.